Professor Juan Bautista Carda works in the Organic and Inorganic Chemistry Department of Jaume I University in Castellón, Spain. Professor Carda likes to read, especially if it's something related to history, and even more if it's about the history of science, as well as about stamp collecting. And he considers himself a modest vocational farmer. But his greatest passion is ceramics. Today we will accompany him on his visit to the Tile Museum, which is a homage to the ceramic industry of Castellón, located in the Spanish Levante coast. This museum has a collection of industrial ethnology with pieces of tools and machinery, photographs and documents from the ancient factories and production processes of the province of Castellón, known for the quality of its clays and for the ceramic tradition of its people. The industrial development of this region, centered on the so-called ceramic monoculture, started at the beginning of the 20th century when the mass production of ceramics began. The Great Crisis of 1931 was devastating to the ceramic industry. After the Civil War, production resumed slowly, and it was starting in the 1960s that a true explosion in the ceramic industry took place. It was then when machinery, little by little though definitely, substituted human hands, which were once the main tools used by this industry. The museum is a witness to the technological changes that have been taking place throughout these years in the Spanish ceramic industry. Walking through this museum constitutes a rather educational itinerary. It explains the why of ceramics, its birth, development, its contribution to culture. From its initial uses for buckets to its use in construction material in the shaping of bricks, shingles, tiles, and azulejos, both for walls and pavements. Of the latter, there is a great collection that spans the classical and Paleo-Christian era to modern times, passing through Spanish Muslim floor tiles and the Renaissance, Baroque, Rococo, and Neoclassical periods. But every visit should start in this workshop.
Hola Max, buenos días.
Buen día, Juan.
¿Cómo estás?
Muy bien. ¿Posar la bata?
He querido venir aquí porque aquí es donde mejor podemos ver cómo se transforma la materia, cómo la arcilla se puede convertir en barro moldeable primero y después en una cerámica.
¿Tenemos a moldear una pieza?
Sí.
Espera que te dé un poquito más de barro.
Bien.
Le das unos golpes.
Gracias.
Si le quitamos todo el aire. Yo te voy preparando.
Se nota que esta arcilla es muy plástica, ¿eh?
Sí.
Cómo se queda la forma.
We know that ceramics have existed since the Neolithic period, some 6,400 years before the Common Era, when buckets became necessary to store what remained of the harvest. Since then, ceramics have always had a prominent role in the cultural life of all the people of the world. And their raw material has always been clay. Clays are, mineralogically speaking, phyllosilicates with a very fine grain and morphologically laminar, which facilitates the interaction with a multitude of substances, especially with polar compounds such as water, hence their plastic and rheologic properties. Red clays that are used as raw materials in the tile industry of Castellón are known in the ceramic sector as Moreau Clays, since their mining ore can be found in the town of San Juan de Moreau. The mineralogical composition in these mines is quite uniform and thus quite appropriate for the processes of industrial manufacturing. Moreau Clay, one of the most highly valued in the world, was a part of the origin of Castellón's ceramic industry. Among the most important properties of the clay in these mines, as compared to other raw materials used to make red ceramic paste, are their high compactness and low plasticity. The ceramic process begins with the selection of raw materials that are usually used exactly as they are when they're extracted from the mine or quarry. It is most important to ensure a previous homogenization in order to guarantee the continuity of its characteristics so that the properties of the product, both when raw and when cooked, don't vary. For this, homogenization systems are used in atomization plants. Clays are untangled and dissolved in stone and water mills. Their particles are thus dispersed and reduced until they reach a size inferior to 200 microns. The resulting suspension is known as barbotine. For the later compacting processes, it is necessary to reduce the barbotine's water content, which is done generally through atomization drying. The barbotine is pumped, pulverized and dried by subjecting it to a flow of hot gases inside these giant atomizers. From this process, an atomized powder is obtained, made up of spherical granules that are hollow and quite uniform, which means that the resulting powder is quite fluid. The atomization process supposes a significant advancement in the production process because this fluid powder is ideal to fill up the tile modes and to be pressed. Jaume I is a university whose aim is to educate the new generations of technicians who will help maintain the Spanish ceramic sector at the top of the industry. For a long time, the ceramic industry in general, and the ceramic tile sector in particular, was considered to be somewhat removed from the world of research, more in line with tradition. It was equated with unfinished chemical reactions, little control over set reactions, and with a high degree of pollution. With this stigma, it was difficult to link this ceramic sector to what's known as advanced ceramics, in which important developments for the advancement of technology have been achieved, such as the microchips found in every computer, although both ceramic technologies are, in essence, similar. Nowadays, the ceramic sector requires a more scientific focus and an excellent level of research in order to implement the innovations of advanced ceramics to the traditional field of ceramic tiles. For that, the Jaume I offers its students and its professors technologies that allow them to remain at the vanguard of research.
Bueno, os voy a pasar ahora dos estructuras cerámicas. Una es la espinela y la otra es el silicato de circonio o circón. Esas estructuras constituyen dos tipos de minerales muy importantes que se utilizan en cerámica. El circón da propiedades ópticas de opacidad. En la estructura de espinela es la que utilizamos para configurar otro tipo de materiales cerámicos, pigmentos cerámicos. Pues bien, ahora vais a ver a través de las cámaras cómo representamos tridimensionalmente estas estructuras. Y esa imagen virtual la conseguimos a través de lo que se denomina la realidad aumentada. Permite ver cada uno de los planos y ejes cristalográficos, ¿de acuerdo? Te doy la de circón y tú puedes ver la de la espinela. Como estáis viendo, en la estructura que tenemos abajo se representa el silicato de circonio. En ella se constituyen unas estructuras muy compactas a base de tetraedros y de octaedros. ¿De acuerdo?
Jaume I University is among the top Spanish universities in terms of the external resources it obtains for research and development per professor. It also has its own well-funded R&D plan. Jaume I University currently offers 28 different degrees. Course curriculae include internships in companies and institutions for 100% of its students. It has about 13,000 students, an amount that allows for each to receive personal attention without the problems of massification. Students here have the most modern facilities available to them. What's more, 1 out of every 4 students is hired by the company they intern at. One of the pillars of this collaboration between the university and companies is the Ceramic Technological Institute, ITC, a co-educational semi-private institute that exists thanks to the agreement between the Association of Industrial Ceramics Research and Jaume I University of Castellón.
La competitividad de las empresas está íntimamente ligada a su capacidad para innovar y cualquier contribución que se pueda hacer en favor de potenciar esa competitividad o esa innovación, pues es una aportación. En ese sentido, el Instituto de Tecnología Cerámica, a través de la universidad, ha contribuido a la innovación tecnológica en las empresas del sector cerámico, aportando 2 de los 3 elementos fundamentales que necesita toda empresa para innovar: capital, personal cualificado y tecnología. Pues bien, de estos 3 elementos, la universidad, a través del Departamento de Ingeniería Química y del Instituto de Tecnología Cerámica, ha aportado tanto tecnología como personal humano cualificado al sector. A partir del año 91 se puso en marcha una carrera de ingeniero químico en esta universidad para formar lo mejor posible en ciencia y tecnología de materiales cerámicos a los graduados. Hemos puesto en marcha muchas líneas de investigación que han conducido a la generación de tecnología que se ha aplicado en el sector cerámico.
The success of the ITC is based on its capacity to synergize with companies and institutions. It is an example of how a balance between education and research can be struck. The success of a modern university is based on procuring economic incentives for research. Jaume I University offers a degree in chemical engineering whose faculty constitutes 80% of the entire staff of the ITC. About 70% of these professors are involved in research projects.
Nosotros realizamos básicamente 3 tipos de actividades. En primer lugar, lo que denominamos actividades de investigación y desarrollo y asesoramiento tecnológico. La I+D que hacemos es básicamente aplicada. Si hacemos algo de investigación básica es siempre pensando en su aplicación a medio plazo. Tenemos, por otra parte, lo que habitualmente se conoce como análisis y ensayos. Y después tenemos una actividad de formación.
The task of analyzing, testing, and certification of materials and ceramic pieces for the industry the ITC undertakes has endowed the sector with an official system of quality guarantee. This is one of the requirements of the Spanish ceramic industry cluster, and it is a product of the high level of current development in the Spanish industry of production of ceramic tiles, thus stimulating competitiveness and the growth of the sector.
A todo ello hay que añadir 4 laboratorios, que son los que básicamente hacen los servicios avanzados. Un laboratorio de análisis químico, un laboratorio de caracterización física, un laboratorio de composiciones cerámicas y un laboratorio de producto acabado, que además permite certificar oficialmente la calidad de los productos cerámicos. Con todo ello, ¿qué pretendemos? Pues lo que pretendemos al final es dar un servicio al sector cerámico que nos rodea. Nosotros estamos en un área donde se encuentra concentrada aproximadamente el 95% de la producción de baldosas cerámicas española y a su vez España es el segundo fabricante a escala mundial, el primero es China. Nosotros nacimos y nos consideramos un centro al servicio del sector cerámico español y también estamos colaborando en diferentes proyectos europeos, incluida una red de excelencia en materiales avanzados.
The ITC, then, is a true technology partner of Spanish ceramic companies. It has been striving for 40 years to provide solutions to the needs and requirements of the industry. It is important to realize that many of these companies, because of their size, do not have the technological means they require. It is precisely because of this that the ITC actively promotes the transfer and spreading of technology and knowledge to ceramic industries. One of the lines of technological specialization in which ITC has reached its greatest achievements is its development of new frits, enamels, and ceramic colorants, which confer new and improved functional and aesthetic features to ceramic products. Another line is the improvement in production management using robust manufacturing processes that contribute to reduce costs of production and to improve efficiency and energy consumption, as well as better respecting the environment. This research also leads to the generation of new technologies that offer innovation to manufacturers of machinery for ceramics. The existence of research that is intimately linked to education and the success of the innovative contributions of Jaume I University relative to new uses of ceramic products has encouraged students from all over Spain, Europe, and Latin America to enroll in degrees that are related precisely to technology and experimental sciences. Jaume I University is located in an area of industrial monoculture, the so-called Castellón ceramic cluster, which encompasses over 90% of Spain's ceramic tile production. This fact has determined the aim of its studies and its research, which have naturally adapted to the demand of the companies of this industry.
La baldosa cerámica queda recubierta por un esmalte opaco o transparente, pero por sí solo no da color. Hay que añadir un agente colorante. ¿Qué ocurre? Al sintetizar un pigmento cerámico hay que introducir agentes fundentes, porque las temperaturas de su síntesis son muy altas. Estos agentes fundentes, además de permitir disminuir la temperatura de síntesis, tienen el inconveniente que son muy agresivos hacia el medio ambiente. Una de las ideas que se ha desarrollado en los trabajos de investigación es utilizar vías de síntesis más químicas. En las vías alternativas lo que utilizamos son precursores de agentes colorantes, como sales de los iones cromóforos, como las que tenemos aquí.
One of the fields of research in which very important improvements have been made, the decrease of polluting emissions. The process of ceramic production produces combustion gases that come from the volatilization of the raw materials and from the particles dragged by combustion gases as they exit the oven. But nowadays, these gases are reused in the production process and are not emitted to the environment. Companies have developed a series of proper environmental practices and used the best available technologies in order to preserve the environment and impact it as little as possible. Nowadays, and thanks to a cutting-edge research process, the ceramic industry is one of the ones that least pollutes the atmosphere, since it is almost 15% under what the Kyoto Protocol stipulates. These chimneys only emit water vapor. It's time to see the inside of a ceramic tile. A ceramic tile is made up of a clay base and a vitreous surface layer known as enamel. Between both components, there is an interface known as engobe, which serves to isolate the clay support from the vitreous surface and also to hold them together through their dilation coefficients. Ceramic enamels are made up of ceramic pigments, substances that generate the color in the enamel, and by melted raw materials known as frits. Frits are vitreous compounds insoluble in water that are obtained through fusion at high temperatures followed by a quick cooling. The use of frits has many advantages, such as the broadening of the work temperature interval of the enamel, but above all, it diminishes dangers associated with toxicity. The current research lines encompass all parts of ceramic tiles, from the base to the pigments, frits, and enamels. But before talking about innovations, it is important to become familiar with the manufacturing process of ceramic tiles.
El polvo atomizado es hueco, puesto que la eliminación del agua se produce de manera muy brusca dentro del atomizador y da lugar a un gránulo no compacto, sino hueco, lo cual favorece también la facilidad de prensado de estos gránulos cuando se colocan en la prensa. Se descarga ese polvo atomizado desde el silo y se alimenta al carro de la prensa. Estas prensas son unidireccionales, es decir, prensan en sentido vertical a elevadas presiones para compactar ese polvo atomizado. Los gránulos son rotos, literalmente, de forma que vuelven a aparecer las partículas primarias que se han obtenido durante la molienda, que se habían aglomerado durante la atomización, y se van adhiriendo unas a otras por la acción de la prensa y de la humedad que actúa como fluidificante, y dan lugar a la baldosa cruda con suficiente consistencia como para ser transportada. Tiene una humedad que hay que secar. Ese secado se realiza en secaderos verticales u horizontales, de forma que la pieza a la salida del mismo tiene una humedad residual del orden del 0,5% aproximadamente. No se seca más porque cuando una pieza cerámica se seca por completo se vuelve muy frágil y va a ser esmaltada y va a ser decorada, es decir, se la va a someter a determinadas acciones mecánicas. Si la pieza fuera demasiado frágil, se correría el riesgo de que se rompiera con mucha facilidad. Esa pieza va directamente ya a la línea de esmaltado, donde se le aplican diferentes capas de engobe y esmalte. Los engobes son materiales de interfase entre el soporte arcilloso y el esmalte que se va a depositar sobre él. Encima de esta capa de engobe se deposita una capa de esmalte base sobre la cual se realizará la decoración. Y a continuación viene la etapa o las etapas de decoración, que en estos momentos son múltiples y complejas. Puede llegar a haber hasta 10, 12 o 14 capas depositadas consecutivamente para dotar la pieza con un determinado efecto. La técnica se denomina hueco grabado. Hace uso de un rodillo que previamente ha sido grabado mediante incisiones con láser. Se introduce en ellas la tinta que posteriormente el rodillo transferirá a la superficie de la baldosa. Ya hay máquinas que permiten decorar por inyección de tinta sin contacto baldosas cerámicas, a semejanza de lo que ocurre en el sector gráfico, por ejemplo. Y se puede conseguir una flexibilidad enorme en cuanto a decoración en la medida que se vayan cambiando los archivos que hacen funcionar ese sistema de impresión.
A highly automized process in which the robotization processes are the almost absolute protagonists and which impresses us laymen with the beauty of modern industrial manufacturing technology. A kind of technology that is undergoing so much development and evolution that we are constantly amazed by it. Technologies that are common and applicable to many industries, but that, for example, in drying processes, have had their origins in the lines of industrial ceramic production. In the field of machinery for chemical engineering, there is total interchange. Almost everything that is researched in one field is applicable in another.
Y el paso siguiente y crucial es la cocción de esa baldosa. La cocción de las baldosas se realiza en hornos de los denominados hornos monoestrato, hornos de rodillos, y con ciclos muy rápidos de cocción, del orden de 50 minutos, 60. El funcionamiento de estos hornos es muy sencillo. El horno tiene una cámara relativamente baja, sí muy ancha, para poder introducir muchas baldosas al mismo tiempo. Funcionan a gas hasta alcanzar las temperaturas máximas, que están entre los 1100 y los 1200 grados centígrados. La llama está en contacto directo con las piezas, con las baldosas que se están cociendo. Están muy optimizados desde el punto de vista de la recuperación del calor a los efectos de reducir el consumo, y están estudiados de tal manera que los gases calientes que se generan se reaprovechen para precalentar las baldosas en las primeras etapas de la cocción. Es muy fácil con este tipo de hornos producir una gran cantidad de material en tiempos muy cortos. Las piezas, una vez cocidas, se someten a la clasificación o al control de calidad. Básicamente lo que hacen es determinar características, por un lado, dimensionales. Las baldosas cerámicas deben ser todas del mismo tamaño. Por otro lado, las baldosas deben tener unos estándares de planitud, que son los que se controlan en estas líneas de selección. Se realiza también un control de la superficie, de la cara vista de la pieza. De lo que se trata es de ver diferencias de aspecto entre piezas. La baldosa cerámica es un producto industrial y su uso está basado en la constancia en propiedades, incluidas también las estéticas.
The intrinsic characteristics of ceramic tiles make them usable in many environments. They are present in many areas of everyday life, basically as pavements and linings. But beyond traditional uses, Jaume I University has invested in researching new functionalities of ceramic tiles on the creation of next-generation tiles, which incorporate cutting-edge technology. Professors Carda and Moreno have been in charge of many of these research projects.
Mi pasión por la química nace ante la búsqueda de lo desconocido, el poder investigar y desarrollar nuevas propiedades y nuevas aplicaciones que generen posibilidades en el campo de los materiales cerámicos. Los proyectos que llevamos a cabo en la Universitat Jaume I van dirigidos a la investigación y la innovación para obtener propiedades tan dispares en las baldosas cerámicas como son de tipo bactericida, de tipo fosforescente o incluso propiedades eléctricas, generando de esta forma unas propiedades cálidas en la propia baldosa cerámica, hasta el punto de que también podemos modular esas propiedades y conseguir en la propia baldosa que actúe como un generador fotovoltaico al interaccionar con la luz del sol y generar así la corriente eléctrica en las propias baldosas cerámicas.
These functions are destined to improve aspects directly related to the quality of life, considering the living conditions of each environment. And not only in the household, public places are also ideal sites that require results that combine functionality and technical features. Research has been directed at endowing ceramic tiles with properties that make them ideal to withstand heavy traffic, to facilitate accessibility to the elderly because of their anti-slipperiness, or which serve as luminescent signals, among other uses. This research is the world our documentary will delve into. New functionalities, new properties, have basically emerged from research into enamels and glazes, which are the tile layers for which new components are researched. It is the enamel which provides it with most of its improved properties and which confers tiles with new functionalities. Researchers cannot forget that only by optimizing costs as much as possible will new materials be competitive with respect to traditional ones. And all of this without affecting their aesthetic features, which are key to their marketing and upon which future research will always be conducted. Because did you know, for instance, that red is still the hardest color to find in industrial ceramic production? For some time, researchers have focused their attention on obtaining ceramic tiles with antibacterial properties in order to facilitate the use of ceramics on the walls of hospitals, medical centers, or places in which sterilization is an indispensable condition. Researchers have developed antibacterial properties in an enamel with a glass ceramic nature. Glass ceramics are those in which crystallizations occur inside a vitreous material. The mechanism of the antibacterial phenomenon is based on a reaction that is photocatalyzed by the incidence of light on the enamel. This incidence elicits a change in the structure of the materials it is made of, belonging to the rare earth group. The new structure requires less oxygen than the previous one, thus freeing the extra oxygen, which in turn interacts with the cytoplasm of the bacteria, causing it to die. Due to the nature of this phenomenon, the antibacterial process occurs in the presence of light. It can be repeated as many times as there are incidences of light upon the tiles, which guarantees its long-term functionality. Another success of the researchers of this university has been the development of anti-slip tiles. Tiles that don't difficult the act of walking, but rather make it possible, especially among the elderly and the disabled. These tiles also prevent irregularities, the accumulation of water, dirt. The person in charge of conducting the trial walks on the surface to be tested in an erect posture and looking downward, taking short steps forwards and backwards. The inclination of the plane is increased until it reaches a critical area, which determines the material's no-danger security limit and which allows it to be catalogued in groups of anti-slip classes. A highly successful project is the development of ceramic tiles with long-term phosphorescence. These special enamels, upon being illuminated, accumulate phosphorescent properties. The key to this research has been precisely to extend the duration of said properties. This research has opened up possibilities of multiple applications for the use of ceramic tiles, as escape route markers in areas that have become dark as a result of an interruption in the supply of electricity. Ceramic materials add their constructive and decorative advantages to these properties, as well as the ease with which they are cleaned, rendering them virtually everlasting, an unbeatable feature when compared to other phosphorescent materials such as paint. There are many places in which the accumulation of an electric charge can be dangerous. Among the most common of these are explosive warehouses, hospitals, operating rooms, and areas in which there are electrically active instruments. Labs with high-resolution electronic microscopes are an example, such as this one in Jaume I University's Central Service of Scientific Instrumentation, where the molecular structure of ceramic materials is studied. In all these cases, it is not as convenient to use traditional ceramic tiles nor other linings that serve as electrical insulators, since they elicit the creation of static electric charges. Researchers studied the different resistivity values typical of the parts of a ceramic tile. That is, of different ceramic bases, the engobe, and of different types of enamel. They decided to act on the latter, the enamel. To achieve the desired anti-electrostatic effect, they thought of creating an enamel with the capacity to generate a surface electrical conduction, based on the semiconductor system antimony tin oxide. The conduction mechanism is based on the formation of areas of greater conductivity in the enamel, due to the fact that the semiconductor system is formed on the surface of the particles of tin oxide. The installation requires the use of a metallic net that allows the electricity to be discharged to the ground, the use of adhesive joints that also conduct electricity, as well as the assurance that the enamel will remain in contact with the adhesive. Thus, the conductive nature of the anti-electrostatic ceramic tile requires a method of installation that will ensure that the conductive capacities of the enamel are fully taken advantage of. Traditionally, ceramic has been considered a cold material, in contrast to other materials used in pavements, such as wood. The development of ceramic tiles capable of generating heat allows for the consideration of a hot ceramic. Thus, a new field in the development of new properties of ceramic tiles is opened, one that enables the discoveries that have been made in advanced ceramics to be applied to traditional ceramic. In order to achieve this, a tile with a resistance circuit was conceived, so that when a potential difference is applied to its conductive enamel, heat is generated because of the Joule effect. The heat generated produces an increase in the temperature of the piece. The challenges of this research affect both the base as well as the enamel. In fact, in the case of the enamel, it must allow for an adequate amount of electrical conductivity, and it must be capable of generating heat throughout all of the enamel surface. The ceramic base must be a true electrical insulator for two main reasons: to prevent losses of electrical charge and of heat generated on the surface of the enamel, and as an additional measure of security. The tile is covered, on top of the conductive enamel, with another enamel that is an insulator by nature, thus ensuring proper security controls that allow its use without any risk, which means they can also work at low voltages. There is insulation on top of the tile as well as on the bottom, thanks to the ceramic base, which makes it a thermal accumulator as well as an electric insulator. In order for the electric current to reach all of the tiles, a plastic conductive joint covered in an insulating joint is used to ensure the security of the installation at all times. On the other hand, the electric flow must reach all tiles without all of them being in contact with one another, since this would lead to the collapse of the system. Since a flow of alternate current is used, there are no poles, neither positive nor negative. The difference in color between both cables of the animation helps explain that each ceramic tile must be connected to both phases of the alternating current. The final proposed installation, whose use will be specially welcome in health and bath-related areas, allows for the regulation of temperature of the ceramic floor at any time, creating a much cozier and warmer environment. Ventilated ceramic facades are another successful application for traditional linings. In recent years, the use of large format ceramic materials for the exterior lining of facades has increased. The development of new materials such as porcelain stoneware and the appearance of new placement techniques and anchoring systems have given way to this new constructive solution. It unites the energy-saving advantages of the building's insulation with the aesthetic ones, and thus becoming a full-fledged component of sustainable architecture. Another line of research that has been developed is linked to the use of photovoltaic cells, that is, elements that generate electricity from sunlight. This project consists of mounting conventional voltaic cells on the surface of ceramic tiles during their manufacturing process. Thus, solar panels can be integrated into architectural structures in which these elements can be used as roof lining or as a combination of energy transformation and more typical tile uses, such as thermal and acoustic insulation. Thus, we see how researchers at the Jaume I University who are undertaking various processes of research and development are obtaining ceramic pavements and linings that provide better solutions to our current needs, both aesthetic and functional. This research has obtained a bevy of new, previously unexplored functionalities for the ceramic tile. It's possible that many more will appear along the path current research is taking us on, considering that the ones we've obtained have gone from the project stage to being established as a tangible reality in today's market. Currently, the Spanish ceramic tile industry is one of the most dynamic and innovative industries in Spain, which is leader in the worldwide ceramic sector in terms of technological development, design, and product quality. We are understanding how research applied to the new ceramic materials can revolutionize the future of something like the ceramic tile, which is so traditional and such a part of our everyday lives. This research on ceramic materials takes place in the Jaume I University, as we have already seen, in broad collaboration with companies in the industry. Many of the companies of the ceramic sector, though they earn over 4 billion euros as a whole, are usually small. Although they are rightfully regarded for their great will to innovate, it is undoubtable that their research and development efforts have been motivated by both Jaume I University and the Ceramic Technology Institute, which offer companies a series of services that widen their technical scientific capacity.
La Universidad Jaume I tiene una intensa relación con el mundo socioeconómico que le rodea, fruto de que su nacimiento como universidad en el 91 se debió a el empeño, a el énfasis que el entorno socioeconómico puso. Y ello se refleja en que la Fundación Universidad Empresa, hay más de 50 empresas adheridas como patronas, cosa excepcional dentro de lo que es el mundo universitario español, ya que el mundo empresarial se involucra en muchas de las actividades de la universidad de una forma altruista. Por ejemplo, están en los planes de estudio aconsejando los perfiles formativos de nuestros titulados o están fuertemente involucrados en las estancias en prácticas. Evidentemente, el sector empresarial que destaca por su magnitud es el cerámico, que en la industria de Castellón reúne más del 90% de la producción de todo el país, y España es la segunda productora mundial de baldosas, de revestimiento, de fritas, de todo lo que es el ámbito cerámico. Son empresas altamente tecnificadas, son empresas que requieren de la innovación y de la investigación continua para desarrollar su tarea y que, por lo tanto, en la universidad encuentran un aliado excepcional para desarrollar su labor.
Inmediatamente de la creación de la universidad, un grupo de empresarios creamos la Fundación Universidad Empresa. Y el ánimo y el primer objetivo de esta fundación era precisamente tender esos puentes entre la sociedad y la universidad. Yo creo que el camino de la colaboración de la universidad tendrá que ir, en primer lugar, en incremento tecnológico. Aplicación de tecnologías de ultimísima generación. Yo creo que las nanotecnologías tienen unas posibilidades inmensas para cambiar el concepto, la fabricación y las propiedades de los productos cerámicos, y ahí tenemos la obligación de ser líderes mundiales.
Castellón de la Plana can be proud of its young but modern university campus. Jaume I is a university nestled in the city of Castellón de la Plana, on the Mediterranean coast, which is the capital of the second most mountainous province in Spain, albeit its somewhat deceptive name. Castellón comes from the Latin Castellone, a diminutive form of castle, and plana, which means plains. A city that today, notwithstanding the social drawbacks associated with development throughout the world, still conserves a small city charm and an air of nobility. During the second half of the 19th century, the city began opening itself up to the world. The first modernist buildings and city landscapes appeared, all located in a downtown area that conserves its own identity. It was then that the commercial harbor was expanded and that the avenues that lead to the sea were built. Jaume I University shares its city's appealing geographic diversity, its mountains, and a shoreline. They also share an expansion process that looks to new horizons brought on by culture and tourism, without forgetting industries that for a long time have been the basis of the local economy, fishing and agriculture. The city is surrounded by its own lungs, unique places in which orange blossoms become actual oranges in autumn, and that present the image of the Spanish Levante coast in all its splendor.
Castellón es un mar de naranjos. Yo no me lo imaginaba así antes de venir a España.
Que va, si hubieras visto antes. Ahora, más que cultivar naranjos, cultivan baldosas.
Oh, sí.
Mira, Milena, vamos a recoger unos pimentitos.
¡Qué maravilla de huerta tienes, Juan!
Esto de la agricultura pues, requiere mucha paciencia. Es igual que la investigación, con tus pequeños éxitos y con tus pequeños fracasos.
¿Te ayudo?
Muy bien. Nos van a venir bien para preparar los ingredientes de la paella. Como un buen químico, me gusta experimentar en el arte culinario.
Lo que más le gusta a Juan es preparar una buena paella valenciana con los amigos.
La verdad es que he tenido la suerte en mi trabajo de poderme relacionar con muchos científicos, muchos estudiantes, gentes que son de otros países y de otras culturas.
Jaume I University encourages its own internationalization by having its professors spend time teaching and learning abroad through exchange agreements for students with North and Latin American schools, as well as the European exchange program Erasmus and other special programs such as the International Masters in Peace, Conflict and Development Studies, all of which contribute to the fact that students from 45 different countries have studied in Jaume I University. We live in a world full of changes and uncertainties. What was once vanguard technology is today a thing of the past. Current development and the future of ceramics are leading us towards important technological innovations capable of driving classic industries, thus reducing their dependence on raw and strategic materials.
Tenemos aquí el último microscopio que hemos adquirido, un microscopio de barrido que lleva incorporado todos los detectores de última generación. Vamos a acercarnos, vemos las láminas de las arcillas, vamos a apreciar la estructura fibrosa.
Hay que ver hoy en día cómo han evolucionado estas tecnologías, ¿no?, de caracterización.
Es silicio, aluminio, con algo de magnesio y algo de calcio. Si quieres podemos sacar algún detalle de mayor aumento.
They want to advance more, creating, for example, tiles that are capable of directly taking advantage of solar energy.
Uno de los proyectos que estamos desarrollando en el ITC, con mucha perspectiva de futuro, es la utilización de baldosas cerámicas de gran formato para el aprovechamiento de la energía solar a efectos de calentamiento de agua, lo que se denomina habitualmente la energía solar térmica, que consiste en aprovechar la energía procedente de la radiación solar, que se absorbe por un captador. Esa energía se transmite a el agua, que se utiliza básicamente en viviendas. La baldosa cerámica es un producto que puede actuar como captador. Baldosas, por tanto, similares a esta que tengo detrás. Los resultados hasta la fecha lo que indican es que hay una variable que es fundamental a la hora de optimizar el rendimiento energético del sistema, que es el color de la baldosa. Cuanto más oscura es la baldosa, mayor capacidad de absorción tiene de la radiación solar. Y, por este motivo, esta pieza que tenemos detrás es un tono gris oscuro. Y, asimismo, la textura, que es una textura lo que denominamos habitualmente satinada, no es ni brillante ni completamente mate, también es de las que contribuye a incrementar el efecto bioclimático.
Summarizing, the new applications of ceramic tiles are destined to improve aspects directly related to quality of life, living conditions, and even take advantage of natural sources of energy. New ceramic tiles are now being considered standard elements in architectural structures, endowing the surfaces they line with an ample range of properties and functions without hampering their aesthetic value. Hence, the existence of ventilated ceramic facades or ceramic linings that transform solar energy into electrical energy. And inside homes, besides traditional lining uses, there are tiles today that have sensors that can activate lights, the opening or closing of doors, set off alarms, or detect people moving about without them having to directly touch the surface of the tile. People who walk on heated and, wherever necessary, phosphorescent or antibacterial floors. It's beautiful to think of ceramic tiles as an ancient and simultaneously new construction material that contributes to the humanization of the medium with which we humans interact, that prevent us from tripping or having an accident, that allow us to get off on the right foot, relaxing our senses, allowing the person walking on or around them to be more contemplative, which provide human beings with no less than a little comfort and happiness inside and outside their homes.